So a little review. We got a quiz coming up. So I got a 7-1, 7-2 review. 3 quick examples. Number 1 is from 7-1, and then technically 2 and 3 are from 7-2. So if you guys would, let's get started. We'll normally let you work on this, but it's Corona time. Let's do it together. Okay, so as I take a look, I got inverse trig. I got inverse trig function, so am I finding sides or angles for number 1? I'm looking for an angle. Sorry, Shay, I don't know what's going on. So we got angles here, right? And then inverse sine works in quadrants 1 or quadrant what? 4. Because it's a negative 1/2, I'm going to draw this thing in quadrant 4. All right, so I'm in quadrant 4. This is O and this is H. So working from this angle, this is O, this is H, this is A. So opposite is -1. The hypotenuse is 2, and I don't really know what A is, and I don't really care. I just want to know, hey, what's that angle across from that -1? What do you guys got? What angle from our reference triangles, 30, 60, 90, or 45, is that angle? That's a 30-degree angle. So again, you guys said we're trying to find angles. So my angle is 30 degrees. Go ahead and convert that, and we should get pi over 6. Okay? You go and type that in my math lab, and then on Monday, on the quiz, you're going to get that wrong. Does anybody know why that's wrong? It's negative. Anything in Q4 is a negative angle. It's going down. So that is a negative 30, which makes that a negative pi over 6. So final answer for that one is negative pi over 6. All right, all right. Do you guys have any questions? So I take a look at number 2. I got the inverse cosecant of 2. Okay, if you want to think of this as 2 over 1, that will help. Inverse cosecant works in the same quadrants as inverse sine, so that's 1 and 4. Because it's a positive 2 or positive 2 over 1, I'm going to draw this thing in quadrant 1. Remember, this is Santa's favorite one, h over O. So my hypotenuse there is 2. My opposite is 1. And again, we know what that angle is. What's this angle? What's across from 1 again? 30 degrees. So again, theta is 30 degrees. And if you type that in my math lab, wrong. It's going to say I want a simplified angle in radians. So go ahead and convert that. Divide by 180, put a pi on top. You get pi over 6. Okay? Again, I always have these things memorized. I always remember if it's a 30, then it's going to have a 6 in it for the radians. If you're really bad at the converting thing, well, we have this in your 6-2 notes. And that little pinwheel again. Okay. So if we have all that together. So inverse trig functions, angles. When I see the next one, number 3, again, this is from 7-2, I see a regular trig function, cosine. So that tells me exactly what I'm solving for. What am I solving for? Sides or angles? Yeah, this tells me sides. Specifically, cosine is A over H. All right, so once I know A and H, I'm good to go. Well, if I cover up cosine, they gave me inverse sine, right? Which is a √3 over 2. All right, so basically they just gave me 2 sides of a right triangle. I need to find that third adjacent leg, right? Some of you guys already know what that is and know the answer. Fantastic. I'm going to draw this thing out just so people that are visual people can see this. All right, I've got, again, O and H for sine. That is in the positive first quadrant because it's a positive. So that guy's √3. This guy's 2. And using p-tags, we know what the adjacent leg is. This is opposite, hypotenuse, and adjacent. What's the adjacent leg? 1. Okay? Now, you don't really need to know this angle. I think Lorelei asked that the other day. Do you really need the angle? No. But just for fun, that is 60 degrees. Okay, because it's across from a root 3. Root 3 is a little bit bigger than 1, just like 60 degrees is a little bit bigger than 30. So we end up with 60 degrees there. So if I plug that in, the actual question is, hey, what's the cosine of 60? Well, we have our 60-degree triangle drawn. That's A over H. And that final answer is what? 1/2. Final answer. Okay. So this is really just a Pythagorean theorem type question where you're giving two sides of a right triangle, you got to find the third. Sometimes we have to use Pythags, all right, because they give you a ratio of sides that we're not familiar with. Or sometimes, you know, we got reference triangles. We got a 30-60-90 or 45-45 ratio. And then we can come up with that missing side pretty easily. All right, so that's 7172. Any questions, y'all? No questions. Nada. We got this. Gotched it, huh? Trademarked. All right, ladies and gentlemen, so now we're going to work on 7.3. This is the last part that's on the quiz. It's trig equations. And that's our goals today, is just to solve these things. All right, when we take a look, they talk about the period of sine and cosine. We graph sine and cosine, right? And when we graph sine and cosine, those things started repeating after one full revolution around the circle. So all the way around 360 degrees or 2 pi, right? So that's what this thing says. All right, so it says the sine of theta plus 2 pi k, where k is any integer like 1 or 2 or 3 or 4. Okay, that's the period of sine. Basically what this is stating, guys, I'm going to take a little sticky note here so you kind of visualize. They're just saying, hey, the sine of 30 degrees is the same thing as the sine of 390, because 30 and 390 add up to what? Is 360 away from each other? Right? Oh, yeah, sorry, I didn't do that. So again, 30 and 390 is one full revolution. It'll put you right back in the same spot, right? And then if I do multiples of 360, if I add 360 to 390, what does that put me at? 750, right? These are all equivalent, 750. And if I want to, I could keep going and adding 360 over and over, and I'm going to get the same thing. Okay, that's what this represents, theta plus 2 pi. I'm just doing it in terms of degrees so we can visualize this. All right, so right now I'm going to focus on the sine and cosine. That's 2 pi k for the property, and then we'll explain how we're going to use that. So as I take a look, example 1 and 2 says solve each equation and give a general formula for all of the solutions, and then list 6 solutions. All right, so when I take a look, I got sine of theta is root 3 over 2, and we want to solve for theta here, okay? Well, when I take a look, it's a positive root 3 over 2, so I got to know how many solutions I got. And this is where we take this all students take calculus and identify where is sine positive, because it's a positive root 3 over 2. This is going to tell me how many different triangles I need to make. All right, so where's sine positive, guys? Positive in what? All students take calculus. All 3 of them were positive, right? So quadrant 1, and where else is sine positive? Quadrant 2. Okay, so I'm going to have 2 triangles. So the first triangle, quadrant 1. And again, I've got O and I got H. We're working from this angle here. We all agree this is O and H. This is A. So I got opposite is root 3 and hypotenuse is 2. All right, so then I should be able to come up with this angle here. What's that angle? Theta. What's across from root 3's? Yeah, 60. Again, convert that. That's pi over 3. Okay? So they're asking us to come up with a general formula to come up with multiple solutions here. Okay, and what the formula is going to look like is that solution and then add multiples of that with 2 pi. So this is where I get 2 pi k. Okay, so this formula is that answer plus multiples of 2 pi, which we represent as 2 pi k. So again, that's like, hey, sine of 60 is the same thing as the sine of 420, which is the same thing as the sine of 780 going around 360 degrees. It's going to put me right back in the same spot. Okay, so I've got my one formula here. So far, so good. The next thing we're going to do is the 6 solutions, but let's finish the other triangle before we do that. So of the 6 solutions, we know one of them is pi over 3. All right, so all students take calculus. We agree sine is positive in quadrant 2 as well. So I'm going to go ahead and draw that same triangle now in quadrant 2. So we're going to use that reference angle where this is root 3 for opposite. The hypotenuse we know is 2 from our root 3 over 2. And don't really care about the adjacent leg. I just want to know, hey, what's that angle? What's this angle again across from root 3? That's 60 degrees. Now, we need theta. Theta is not 60 degrees again. Remember, theta is from your initial side to your terminal side. This guy's theta. That's theta. That thing is always obtuse in quadrant 2. All right, so what's that angle? 120. How'd you guys get 120? Yeah, this is a linear pair, right? This is a straight line, 180 degrees. So if you know one of them 60, then the other one is 120, also known as a supplementary angle. So if you need to, take 180 minus 60, and you get that 120 degrees. Again, convert that to radians. That's 2 pi over 3. So that's my other formula for this one is, for the second quadrant, is 2 pi over 3, and then plus multiples of 2 pi. And again, they want 6 solutions. So we have 2 pi is the second of 6. Okay, so far so good. Any questions where I'm at, what I'm doing? We're okay? Okay, so the last thing is coming up with these 6 solutions. Now think about how many solutions you could come up with. How many possible solutions are there? So I'm at 60 and I add 360. How many times can I do that? An infinite amount, right? So there's an infinite amount of solutions I can come up with. They want you to come up with 6 of them. All right, so I'm at pi over 3 and they want me to add 2 pi. Okay, so here's the idea. Let me get a nice sticky note here. So I'm at pi over 3 and they want me to add 2 pi. Well, if I'm looking at common denominators, I'm going to multiply top and bottom by 3. So here's the idea. I'm at pi over 3 and I'm going to add 6 pi over 3. Right? Do you guys agree 6 pi over 3 is the same thing as 2 pi? Right? 6 pi over 3, 6 divided by 3 is 2. So if I'm at pi over 3 and I add 6 pi over 3, now where am I at? 7 pi over 3. So what I'm going to do here to get the next one in order is just keep on adding, keep on adding 6 to the top. So 7 plus 6 is 13 pi over 3. Okay. Now, some of you guys are not so good with fractions. Okay. That's okay. Take 1 divided by 3. Math frac that thing. Nice, make a nice pretty fraction, right? 1/3. Now I'm going to add 2 pi, so I'm just going to add 2 to that. And there we go. We got 7/3. That's 7 pi over 3. I'm just removing the pi. And then add 2 again. There's that 13 pi over 3. So the people that are bad with fractions, you can still use your calculator. Just keep on adding 2 every time. And math frac it as you're going. Okay. Same thing with 2/3. I'm just going to add that 6 pi over 3 again. I'm adding 2. So go ahead and add 6 to the top. So 2 plus 6 is what, 8? And then add 6 to the top again. 8 plus 6 is 14 pi over 3. And there's my 6 total solutions. Okay, I've got 3 from the first triangle and 3 from the second triangle, and that gives me a total of 6 answers. All right, again, somebody said, well, there could be an infinite amount, right? Because you're going around a circle. You could do that forever and ever and ever. All right. All right, you guys have any questions? So there's your 2 formulas, and there is your 2 solutions, or 6 solutions. All right, so we're switching gears now. So we're going to look at tangent. When we look at tangent, I want you to look at this guy, the period of tangent. When we looked at that graph, we said it started graphing and started repeating after a distance of pi. Okay, so that's even less of a revolution. That's only over 180 degrees. Okay, so basically what that means is for these two, we're going to make 2 triangles most of the time. Okay, which means 2 formulas. And because this is 1 pi, that means I only have to make 1 triangle, which equals 1 formula. So this one's actually kind of nicer. We have to do less work, and I'll explain that, why that is. Okay. All right. So let's take a look at number 2. And I know you're looking at the back and like, oh my gosh, it's going to take forever. I promise the back side is going to be real fast. I think we have 2 more examples on the back. When I take a look at example 2, it says tangent of theta is -1/2. So some of you guys might be thinking circles and quadrantal angles like 90 degrees and 0 degrees and -90. But not with tangent. We said the other day, if you have tangent or cotangent and that equals -1, well, that's where opposite and adjacent have completely reduced, right? And that only happens when opposite and adjacent are exactly the same. So what reference triangle are we working with now? 45, 45, 90, right? Where do I draw this thing? All students take calculus. Where is tangent negative? I know where it's positive. 1 and 3. So it's got to be negative 2 and 4. Now, I only have to draw the first triangle. I only have to do the one in S in quadrant 2. And I'll show you why. When I draw quadrant 2's triangle, again, the idea is this is the tangent of theta is a -√2 over a √2. This is a positive √2, which makes this a -√2. And that's a 2 for my triangles. That gives me that reference angle you guys said 45, 45, 90. And if you say theta is 45, you forgot the big idea in quadrant 2. Quadrant 2 is obtuse. That's theta. So take 180 and subtract 45. What do you guys get? 135. And go ahead and divide that by 180. Put a pi on top. So it's in radians. That's what? 3 pi over 4. Okay. So my formula for this one would be that angle, 3 pi over 4, and then plus pi k, not 2 pi k. That's my formula. Now, when I add pi, when I add 180 degrees, guys, that puts me in this quadrant. So 180 from there puts me there, so then I don't have to do another triangle because this thing starts repeating after just 1 pi. Okay, so I don't need that second triangle. I don't need another formula. Okay? You guys have any questions with that? All right. So last but not least, I need to come up with my 6 solutions. Again, we already have one of them, 3 pi over 4. And what I'm going to do is I'm going to take that 3 pi over 4 and I'm going to add pi to it. Well, if I get common denominators, I'm going to multiply top and bottom by 4. Well, that's 4 pi over 4, right? So just keep on adding what to the top? This is 4, right? 4 pi. So 3 plus 4 is 7 pi over 4. That puts me in quadrant 4. 7 pi over 4 is 315 degrees. Okay, that puts me right there. It takes care of that. So keep on adding 4 to the top. 7 plus 4 is 11. 11 plus 4 is 15. Add 4, 19. Add 4, 23. Now again, some of you guys are bad at fractions. Well, that's okay. 3 divided by 4. Math frac puts it in a nice pretty form there. And I just keep on adding 1 now. So add 1. Press enter. 7 pi over 4, 11 pi over 4, 15 pi over 4, 19 pi over 4, 23 pi over 4. Boom. Okay. When you plug it in, just remove the pi's. You're just worrying about the fractions. Okay. So there's my 6 solutions. There's my formula. Any questions, y'all? No questions. Nada, nothing. Okay. When would I ever use this? Well, calculus. When would you ever use calculus? We want to be an engineer? Make lots of money? Be an engineer. All right. Last but not least, here we go. Example 3 and 4 are going to be a lot easier. These are a little easier because you don't have to come up with a formula and you don't have to come up with 6 solutions. You just have to come up with the solutions that you would see from 0 to 2 pi. But do not include 2 pi. It doesn't look right. Include. I think that's right. With an E on the end? Include? Yeah. I'm a math guy. English, not so good. Sometimes you spell a word and it just doesn't look right. So again, do not include 2 pi. There's no equal sign there. Okay, so this thing, all of my answers are going to be from 0 to 359.99999 degrees. Do not include 360. Okay, because there's not an equal sign there. Okay. So as I take a look at example 3, it says, okay, solve this guy. I got 3 cosine of theta equals -3. And people are freaking out. Oh my gosh. But if you can solve this, 3x equals -3, then you can solve this for cosine. All right, so go ahead and isolate the x. What would you do over here and apply it over here? What would you do? We divide by 3. We're trying to isolate the cosine of theta. So we get cosine of theta equals -1. And now, when you see sine and cosine and you see 0, 1, or -1, we're not doing triangles, we're doing circles. We're thinking quadrantal angles. Okay? So I'll give you my little quadrantal angle cheat sheet here again. 0, 1, 0, IOU. So if that's 0, 1, 0, this one's 0, -1, 0, and this is negative IOU. Again, I is a 1 and U is undefined. Remember, those are in terms of SOHCAHTOA, the three big ones. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Well, we're trying to figure out where is cosine of theta equal to -1. Where do you see cosine's -1, guys? 180 degrees right here. That's where cosine's -1. And if you type in 180, it's wrong, right? They want it in radians. What's 180 in radians? Just pi. Final answer, pi. You don't have to come up with 6 solutions. You have to come up with a general formula. That's it. Okay. If they did want the general formula, you'd only need one of them. Okay. And it would be pi plus 2 pi k. So if you want multiple solutions, that would be pi, and then keep on adding 2 pi. 3 pi, 5 pi, 7 pi, 9 pi, ... But they don't want that. They just want from 0 to 360. Don't include 360 though. Last one, guys, and then we're done. I got 4 sine squared minus 5 equals -4. People are freaking out. Oh my gosh. This is just the same thing as you had 4x squared minus 5 equals -4. What would be the first thing you do on that one? Add the 5 over. That's 4x squared equals 1. So let's do that. That's 4 sine squared of theta equals 1. And then second to last step, what do we do here? Divide by 4, divide by 4. We get x squared equals 1/4. Divide by 4, divide by 4. We get sine squared of theta equals 1/4. Same idea, right? And now we would square root both sides. All right, so we square root. When you square root a fraction, square root the top and square root the bottom. So we should get the sine of theta equals, the square root of 1 is 1 and square root of 2 is 2. But what does Mr. Gotsch always say when you square root both sides? What are we forgetting? No. Don't forget the plus or minus. All right, very good. So maybe make note of that. Don't forget the plus or minus. Okay? So when I take a look, I'm ready to go now. I've got the sine of theta equals positive or negative 1/2. Well, if I think about that, all students take calculus. Sine, regular sine, is positive in quadrants 1 and 2, and it's negative in 3 and 4. So that means there are 4 solutions. I've got 4 triangles I got to make. Okay, so again, this is O and this is H. Let's make our 4 triangles. So first one I'll do in blue. I got opposite and hypotenuse. Remember, opposite is always going to be the up and down one. That's 1, that's 2. What's this reference angle? 30 degrees. So I got theta is across from 1. That's 30 degrees, which is pi over 6. Let's do the next one. Now I'm in quadrant 2 for the other positive 1/2. That's 1, that's 2, that's O, that's H. That's still 30, but I want the big angle. That's theta. Take 180 minus 30. What's 180 minus 30? 150. Go ahead and convert that. 5 pi over 6. Okay, we're halfway done, guys. Now I got to do the negative 1/2 ones. That's in quadrants 3 and 4. Okay, I haven't done green yet, so let's do green. So I have a negative 1/2 now. That's opposite. That's hypotenuse. That's still 30, right? But that's 180 plus 30. It's a little bit past. So what's theta there? What's 180 plus 30? 210. Awesome. That's 7 pi over 6. And then last but not least, I haven't done, let's try red. Quadrant 4. That's opposite. That's hypotenuse. That's still -1. That's still 2. This is still 30. The whole thing is 360. But 30 less than 360 is what? 330. You guys okay with that? Well, that's 330. And that's 11 pi over 6. Final answer is these 4 answers. So I solve this thing. When you square root both sides, a lot of times you're going to get plus or minus, right? That means you're going to have twice as many solutions. Normally it's like, usually it's 1 or 2 solutions, but when you square root both sides, now you got to double that because of the plus or minus. There was 2 triangles for the positives, and there's 2 triangles for the negatives, which gave me 4 angles that answer this question. Okay. Ladies and gentlemen, do you have any questions on 7.3? I'll tell you, most of the questions that I ask on homework are like examples 3 and 4. Okay, I don't really ask too many from the first part, but there is, I think I put one on the quiz that has a general formula, which is a multiple choice question.